lengthwise the same thing and breadthwise the same thing. But on the top of it, silica followed by aluminum stacking. If it is 1:1, once again silica followed by aluminum stacking. Once again silica followed by aluminum stacking. Like this. If it is 2:1, silica, alumina, silica. Silica, alumina, silica. Like this. Clear? Fine. So, now alumina, once again, this is 1-2 gap. That means alumina stacking in gap we need to have. Okay, so in case of alumina, remember, in case of dioctahedral, we will call it gap 1-2. Like gap 1-2. This is not in the book. This I am just mentioning you so that you will be able to visualize, you will be able to understand. Okay, so silica will be following always 1-2, then gap 1-2, like this orientation. So if you want to put it in the C-axis, the aluminum layer, over the gap, there should not be gap. There should be something. So out of two position is to be filled by the aluminum. So it has to be gap 1-2, gap 1-2, like this, right? So in dioctahedral, is this clear now? Clear? Should I go ahead? Okay. So, in case of alumina, say, if it is gap 1-2, then gap 1-2. This is one orientation. And once again, 6 molecules. That means, say I said gap 1-2. That means you put over here, then this, and this. Alright? And on the top of it, so you can so this aluminum 6 shared. Now look, this 1, 2, 3, 4, 5, 6 shared. Now this 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4. This is a continuous one. So it will go on. Clear? So all the aluminum molecules is sharing 6 molecules. Right? So now this I said, say gap, or say 1, 2, the way, whatever the way. Now I will show you the stacking, then only you will realize. So this is what? This is dioctahedral alumina layer, or clear? Fine. Now, what will be the trioctahedral? What I said about the trioctahedral? Tri means out of the 3 position will be there. That means 1, 2, 3, 1, 2, 3, 1, 2, 3. It is very continuous one, right? 1, 2, 3, 1, 2, 3. It will go on. So this is, that means all the charge is being filled. Okay? All the charge is being satisfied. So this is trioctahedral. Now trioctahedral will be what? Say similar. This smallest unit will be something like 1, 2, 3, 1, 2, 3. Something like that. And over it will be the molecules. Okay, now look. Got me? Look, all the aluminum is sharing 6. Right? Any one you take, This 1, 2, 3, 4, then 5 and 6. This 1, 2, 3, 4, 5, 6. Clear? Clear? Not clear? Once again, silica tetrahedral layer is one silica, like it is a process of 1, 2, gap, 1, 2, like that, in A dimension, in B dimension. Now in C dimension, all the minerals present in soil, whether it is 1:1, 2:1, 2:1:1. These are the three types of phyllosilicate present in the universe. Okay, so if it is 1:1, that means one layer of silica. Above that, on the C axis, one layer of aluminum. That is 1:1. Okay. Now 2:1, one layer of silica followed by one layer of alumina, and then one layer of silica. It's a kind of sandwich, right? So this is 2:1. Now all the minerals, the silica will be following, say 1, 2, then gap, 1, 2, this way. Now aluminium, when aluminium staking will be there over it, over the gap, aluminium molecules if it is there, then एक बिल्डिंग में आपने 2 ब्रिक, उसके बाद गैप, उसके बाद 2 ब्रिक, अब उसकी ऊपर वाला जब ईटा लगाएंगे, उस गैप के ऊपर गैप रहेगा तो क्या खाली हो जाएगा ना? So you need to put something over the gap. So in case of aluminum staking, that gap will be filled. Over the gap, molecules will be there. So if it is dioctahedral, that means one will be over the gap and then followed by another aluminum molecules, and then it will be gap, like that. So this is dioctahedral, and dioctahedral, all the sharing dioctahedral sharing, I've shown you, all the aluminum is sharing 6 molecules. This is dioctahedral. Similarly, trioctahedral means all the position is being filled by aluminum. In case of di, out of 3 position, 2 position is being filled by the aluminum, or out of 3 charge, 2 charge was filled, right? So out of 3 position, 2 position was filled by the aluminum molecules in case of dioctahedral layer silicate. But in case of trioctahedral layer silicate, all the 3 position is filled by the aluminum. So in that case, there is no gap. 1, 2, 3, 1, 2, 3, like this. This is the orientation. So, and now all the molecules is being shared. Fine. So now you know the basic structure of trioctahedral sheet or trioctahedral layer, and basic structure of dioctahedral layer of the aluminum trioctahedral layer. So now you know this is the silica tetrahedral layer, and this is the dioctahedral aluminum layer, or this is the trioctahedral aluminum layer. Now, how they do orient, this you have to learn. Now, follow me closely. This I have to put over here only. Then it is 1:1, fine. Now, if it is 1:1, now look, I said this is 1, 2, then gap. That means over it could be one molecule has to be, aluminum molecule has to be there in case of dioctahedral. So another, so I can say it now, this is gap, 1, 2. Then what will be the next following? Gap. Got me? So gap के ऊपर तो रहने हैं तभी वो staking possible. Is that clear? So it has to be 1. Then because this is the smallest unit, so I am taking this so that we can link. So 1, 2, then gap. 1, 2, then gap. It will be going on like this. Clear? Now you do the same thing. The dioctahedral layer. How to draw that? Look, this is shared by the 6 molecule. This 6 molecule is already there. You have to share, no? You have to link it. So another 6 molecule you have to put this. In between gap also there is one. Gap के ऊपर, ठीक? Okay. Now look. This is how I will be drawing this, then this. The same thing, I just put it over here. Clear? Have you heard the name of Linus Pauling? Pauling? How do you know? Pauling, what do you know about Pauling? Pauling exclusion principle. Pauling is the scientist who got Nobel in chemistry, who got Nobel in physics, and narrowly missed Nobel in medical science or biochemistry, you can say. DNA double helix, in fact, it is the work of Pauling. Anyway, it is the Watson and Crick. Actually, there is a wonderful book written by Watson. Have you gone through that book? DNA the double helix. Only a small pocket size 90 pages book. Wonderful book. Contemporary science and the people around, their life, everything has been covered.